In this video, I'm going to talk about deployments, specifically auto deployments. Now, when it comes to auto deployments, it's the whole thing is really crazy. Sometimes people are going to tell you that you need Devops engineers for auto to set up auto deployments and all that. So, but that's not true. You don't really need DevOps team. You just need engineers or someone who knows what they're doing. So what I'll do, I'll go through a couple of stages, and if your company is stuck at stage one, then maybe you kind of need to do some work and kind of modernize your workflow. Yeah, and I'll probably use some terms that you might not know, but so just let me know in the comments if you don't understand anything. But the thing is, these terms are not really that complicated. It's just some people don't understand how to explain them, and it just kind of gets more and more complicated. And at the end, you just kind of give up. So let's start with stage one. If your company is kind of stuck here, then maybe you need to do some work, investigate and see if you can put together a better workflow for auto deployment. So the stage number one is classic deployment. I don't even call it deployment because deployment is a modern term. The stage number one is just pushing the code to FTP, right? So you take your code, maybe you bundle it or something, and you just copy paste it into FTP through FTP clients like FileZilla or something like that. Maybe even using web interface. And I know a lot of companies do that. And if you're a small company, if it's a small site, I don't see too much harm in doing this. But these things are prone to errors. Like if two developers can override each other and things like that. And if you've been doing these, you kind of know the harm this kind of does from time to time. Right, so that's stage number one. And if you're stuck here, then I would definitely say kind of move to upper level. So stage number two is this: you kind of just you have your code, you push it to Git. The code sits on Git server now. Then you SSH into the server, and then yeah, you just do something like Git clone initially, or then afterward you keep doing Git pull, and then your code becomes available on the server, which is completely fine as well. But again, prone to errors. Because let's say you do some testing locally, then the code goes on Git, sits on Git, then you pull it onto to the server, then you realize, oh, something's not working, I don't know why. Then you investigate, you SSH into the server, maybe a function broke something, on the site, but you wouldn't know that until someone reports it. Yeah, luckily, hopefully you find out soon enough, before your company loses money. But that's stage number two. And I think a lot of the smaller companies still do this. Not really bad, but it's prone to errors, and things do go wrong when you do things like this. So for example, if you have suddenly permissions issue or something, something has changed in the server or anything like that, you will have issues. And yeah, there's just again and again SSH into the server and then manually running the commands. Maybe you need to compile something. Maybe you need to run some shell script, npm this, npm that, and all that stuff. And yeah, it can get lengthy running these commands repeatedly. And if one command fails, then what? If one command fails, then you have to fix that, even though it didn't fail locally. Sorry, by the way, if I'm speaking too fast. I need to just go through these quickly because of LinkedIn video limitations. So that's stage number two. If your company is still doing this, there's room for improvement. Think about what else you can do, how you can automate the process and all that. Stage number three is kind of where we start automating the process here. This is how it works. You push the code to Git as usual, yeah, and somehow Git will trigger an endpoint on your server. So you push the Git, or you push it to the Git, and then, or maybe you merge something together, and then once the merge happens, Git is going to call your server. So it's just an endpoint you can configure, and Git is going to call your server with parameters, maybe with the key, I don't know what, but it'll call your server, and then your server can do, let's say, /deployment. If it calls that endpoint on your server, you can run a script or anything, any script, but in this particular case, you can run git pull. So behind the sign, you can run git pull each time someone or Git calls that URL. Obviously, you'll have to make sure that it's not other people calling the URL and it's no index in Google and all that stuff. But that's automated at this point. So Git calls your server runs git pull, and you have the new code done. This is where we start speaking about automatic deployments. Now, because it happens automatically, as soon as you push, everything else happens automatically. it's yeah, it's automated at this point. So stage number 4, um, we push the code to Git, and let me actually look here. We push the code to the Git. Here's the problem: when you push code to Git, Git doesn't do anything with the code itself, right? Let's say you run a test locally, right? You have unit tests in your system. You run them and everything passes. 100 out of 100 tests all pass. Everything fine. You don't see any issue. You've done QA and all that. You push it to Git. Git does nothing with that code at all. Git just keeps the code in their server, right? So you can pull the code on your server later on. So what Git will do, it'll keep the code there, and then you will do git pull or whatever. You'll invoke the endpoint and it'll pull the code. But what happened here is that when the code went from your local computer to Git server, it was not tested. It was not tested at all. It's just sat there, and then from there it ended up on your server. Now there is issues. How do we prevent this second stage of problems? What you can do, you can create an additional server. So instead of, like I said earlier, instead of invoking your production server URL to do git pull, you can invoke another server. Maybe let's call it test server, server 1. Let's call it test server. You invoke the URL on that server. On that server, you do git pull, you get the code, yeah, and then you run PHP unit tests. So in testing server, you run PHP unit tests. If everything passes, what you can do, you can invoke the endpoint of the production server, which does git pull. So you're kind of using an extra server in the middle. So you have Git, you have extra server, and then you have production server. So from Git, the code goes to testing server where you run unit tests. Everything passes. From there, you invoke the URL of the production server that will do git pull again. And at this point, at least you know that my code has been tested on cloud, which is the testing server. So that's the whole point of this stage 4. Now at this point, if you're doing this, it's good. It's actually good. But the only issue is that we have this extra server sitting in the middle, right? Which is not bad, but this is a way to do it as well. So you're kind of just testing the code when it's on the cloud, not just when it's sitting on the local machine before it ends up on the production server. So I kind of hope it makes sense. I've kind of written a LinkedIn post about these as well. So if you want to kind of read those in your own time, maybe I'm talking too fast, but let's keep going. This is stage number 5, Git actions and testing. So before we had a server, right? We had additional server in the middle that would do unit testing, right? And it would invoke the production server. Here, what if you could just eliminate that server in the middle completely, right? What if you could do that? So it's something like this. You have Git, then you have server, testing server, and you have production server, right? So from Git, the code goes into testing server, and then from testing server, it ends up in production server. This is fine. But what if we kind of just eliminate this server, you know? What if we just don't have to do this step? What if we just go like this? This is possible. So what happens is you can use something like Git actions. Git actions is basically a process. Well, the thing is, Git calls it Git action, but you can call it whatever. I'll kind of explain it, how I understand it, and how I use it. Git action allows you to, is basically a process that spins up a server. So if you push something to Git and it triggers the Git action, what you can do, you can create a server on fly. Basically, that's it. So you can create a Ubuntu machine on fly like this. Okay, so now that middle server is no longer there. So you have something like Git, you push up, and it triggers Git action. Git action, you see that? Git action. From Git, you push it up, and then it triggers Git action. Git action spins up a server. So Git action will spin up a server for you, and in this server, what you can do, you can run tests. So you can do things like PHP unit, right? So this will run tests. Now, what happens next? Once the Git action has run the tests, if the test pass, what you can do, you can SSH into the server from Git action and pull your code. You see that middle server has been eliminated, and we're using Git action, a service by Git, mostly free, to create new servers on fly. So as soon as Git action ends, the server disappears as well. So you don't have that middle server. You don't have to keep paying for that middle server. So let me just kind of go through this from the beginning. You have code on local machine. You push it to Git. Git triggers Git action, creates a new server. In that new server, you um, run your things, like maybe you want to compile things, you want to run PHP unit, um, maybe you want to run other commands, maybe you want to go through the files, coding standards and all that. Maybe you want to clean something up and all that. Um, that's what Git Actions does. And then in the end, you can SSH into the production server from Git Action and then pull the code. So this is stage number 5. And if you have this, something like this set up, I think you're doing pretty well. I don't think you need to go beyond this. Most of the small companies, you don't need to go beyond this. But let's go to final stage. Let me just copy this so I can explain it better here. So final stage is pretty much the same, but it introduces a complexity here. The complexity is Docker. So let me explain here. You have Git local, you push it up, then you trigger Git action. Git action spins up a server, right? Now, then you run the test, right? After this, what you could do, you could okay, let's look here. It spins up a server, but what sort of server, right? What sort of server is going to spin? Ubuntu, yeah, but there's many other things that go into the server. What you could do, you could have here, you could have Docker image in your code. So whenever it's spinning up a server, creating a new server, it can use that Docker image to create that server. So server is created in a way that you expect it to. Right, so if you specify this dependency, Apache, Nginx, this type of folder structure and all that, Docker image can dictate that. So when you create a server, Docker image can say, create me this type of server, create me these sort of permissions, create me this sort of structure, install me these dependency, install me Nginx, install me this library and all that. Even run me composer install, pip something with Python. You can do that. You can specify that in Docker image, and Docker image will execute in the Git action, right? So Docker image is messing up the terms here. So Docker file will create a server in Git action, right? Once it creates a server, what you can do, as soon as it has created a server, you can kind of just go and take a snapshot of the server. So once you take a snapshot, what you can do, basically snapshot or image, I'm kind of mix the terms so you understand it better. You can kind of create a snapshot and push that snapshot to Docker Hub. Now you have your code packaged into something that's similar to operating system. Everything is the same. It has been tested, unit test has been compiled. Now it sits in that image or a file or whatever you want to call it. Then you push it up to Docker Hub. Once it's available on that Docker Hub, the code on your production server can pull that image. Yeah, pull that image and create a container with that image. Once you have a container, you'll have code that an exact copy of the code that was on Git action earlier. And we made sure everything works. We compiled stuff, we tested it, and it's an exact same copy, but now it exists on your production server, and you can just start a container. Container is just a process. Just kind of just kill the old container and start a new container, and you have that exact same code that's been tested, and it's the exact same copy. Everything is the same, and now you can be sure that, yeah, my code will probably work because it's been tested literally just now on cloud, and I have exact same image copy of that. We call it Docker images, but yeah, you have exact same copy. But this is kind of like stage 6, and a lot of the bigger companies do this. You don't have to go this far. You don't have to go all these Docker images. It gets really complicated. But I would say at least have something like this in your company. Push the code up. Run Git action. Do some testing. Use some basic testing. Unit tests and all that. You should be writing unit tests anyway. Unit tests, and then obviously you can SSH into the server and then Git pull automatically. So it kind of just saves time, because a lot of times when you have code, it kind of requires you to do other things as well. It kind of requires you to clean up. Sometimes you have to restart certain services. You have to structure things in a way. You have to compile. You have to run other commands. Plenty of commands you have to run depending on the language. But stage 5 is kind of good position to be in. But I'll say if your company is stuck here, then I don't know what you're doing. Like, honestly, I don't want to be mean, but don't do these sort of things, at least in 2025.